So let me first share my screen. And I am one of the TA for this course. I am from Civil Engineering Department, IIT Kanpur. So let's go to first question. So the first question is, in a half reaction involving nitrate and ammonium, if the PE is 8 and pH is 7, the ratio nitrate to ammonium comes out to be this. What is X? And a hint is given that we have to first work out with the balanced half reaction. We have to balance the nitrate to ammonia reaction, and then we have to start using equation for finding out the ratio. So I'll give you all 5 minutes because it is a numerical based question. So just take your time, try to solve the question and write what value you are getting for X. So please try to solve the question and write your value in the chat box. Okay, let's see how to solve this question. First, we will balance the half cell reaction. Nitrate is forming ammonium. So let's first balance this reaction. Nitrate is forming, not forming, I should say, it is oxidizing or reducing to ammonium. So we know that we basically write in the terms of reduction reaction. So for balancing the reaction, let's first what we do is we balance all the elements except hydrogen and oxygen. So in this reaction, except hydrogen and oxygen, it is nitrogen, and we can see that nitrogen is already balanced. So after balancing of nitrogen, we will balance the oxygen. So we can see that in the reactant side, there are 3 oxygen molecules. So for balancing of oxygen, we will add 3H2O on the product side. Now after balancing of oxygen, we will balance hydrogen atom on both the side. So we can see that we have 10 hydrogen atoms on the product side, but there are no hydrogen atoms on the reactant side. So we balance hydrogen atoms by adding H plus on the side where there is deficiency of hydrogen. So we will add, this is 3 to the 6 plus 4, 10 H plus. And finally, after balancing of hydrogen, oxygen and all the other atoms, we finally balance the charge on both the sides. So on the product side, the charge is plus 1. But on the reactant side, we can see that the charge is 10 plus minus 1, that is plus 9. So we have to balance the charge of both the sides. So we will add 8 electrons on the reactant side so that the overall charge now is plus 1. So this is the overall balanced reaction for reduction of nitrate to ammonium. So first we have to balance the reaction, and now let's see what is given in the question. So it is given that PEA is 8. Okay. And pH is given as 7. And we have to find out the ratio of nitrate to ammonium. We have to find out what is this X. So first we need to find out the value of PE naught, that is at pH 7, temperature 25 degrees centigrades. So for this we will refer table from the reference book which was mentioned in the first lecture. So let's see a table. So I have taken the screenshot from water chemistry book by Benjamin. So let's see where is, so in the third reaction, this is this one, we can see that, no, not the third reaction. We can see in the second reaction that nitrate is forming ammonium plus 3H2O. And for this reaction, on the right hand side, 4 columns are given. The first one is for log K, second is for PE naught, and third one is for PE naught W, in which we consider the pH to 7 and activity as 10 raised per minus 3, and the last column is for EH naught. So we need to find out PE naught. So we can see from the table that is PE naught for this reaction is 14.885. So let's note it down. So we have PE naught is 14 point, I guess it was 885. And we will use this equation which was derived in the lecture slides, that PE equals to PE naught minus NH, that is number of hydrogen atoms, divided by N, number of electrons, into pH minus 1 by number of electrons into log concentration, or I must say activity on the product side, divided by activity on the reactant side, that is nitrate. So here pH is given as 7, P is given as 8. We have seen the value of P not from the table. So what we have to do, we just have to put everything here. So PEA is 8. 8 equals to 14.885 minus number of H plus is 10. Number of electrons involved is 8 and pH is 7 minus 1 by number of electrons 8 log concentration of NH4 plus divided by concentration of nitrate. So after solving this, we will get the ratio of log ammonium to nitrate. So I request you all to please solve this in calculator or calculator in your mobile phone and find out what is the correct value. So the approximate value we are getting is 5.7 into 10 raised to power 19. So So there are three redox couples given and corresponding P naught value is given, and we have to find out which of the couple contains the most potent oxidant and which has the most potent reductant. So you have to find out the most potential oxidant and most potential reductant out of the four options. So I'll give you all 3 minutes. Just take your time and write the correct option in the chat box.
Madam, answer B. Option B.
Okay, but B is not the correct answer. So let's see. So oxidant are those which oxidizes other compound but itself get reduced, and similarly reductant are those which reduces other compounds but oxidize itself get oxidized. So out of these three, the redox couple which will have highest value of Pe naught will be the potent oxidant, because since Pe naught is very high, so it will reduce itself, or it will take electrons and form the reduced form of the compound or element. And similarly the reaction which has the lowest value of Pe naught will be the most potent reductant. So here we can see that the redox couple from Pb4 plus to Pb2 plus has Pe naught value of 28.64. So this will be the potent oxidant, and the couple Al3 plus forming aluminium solid with P naught value of minus 28.54. This is the potent reductant. So simply by looking at the values of P naught, we can find out which will be the oxidant and which will be the reductant. So let's move to the next question.
The answer of second question.
Yeah, yeah,
Madam, second question answer.
yeah. It is A.
This A.
Yeah.
ठीक है. ठीक है.
So the third question is, in module 52, we talk about analogy between pH and PE graphs. Match the following. So based on the base of the given two reactions, that is base taking H plus and forming acid, and any oxidant taking electrons and forming the reduced form, we have to find out what is P naught, A oxidant, A reductant, and electron signifies in the acid base reaction. So again, I will give you 3 minutes. Just take your time and write the correct answer in the chat box.
Madam, answer is D.
Okay, but D is not the correct answer. So let's see. So like in any acid, suppose we are taking HCl, it dissociates in H plus and Cl minus. So if we reverse the reaction like Cl minus plus H plus, it forms HCl. So this reaction and this reaction are same. Cl minus is the base for HCl, base of the HCl. So it is taking H plus and forming HCl. And similarly, here it is a oxidized form of any compound A. It is taking electrons and forming the reduced form. So we can see that we can resemble this reaction and this reaction as first let's see what is Pe naught. So this reaction has some value of log K or minus log K, we write it as pKa. Similarly for Pe naught, it resembles with pKa. So for A, Q is the correct option. Next is A oxidized form of A. So it is similar to the base. So it will be S. For B, it is S. Next is the reduced form. It is similar to the acid. So for C, it is P. And finally, the electrons are similar to the H plus ions. So D is R. Answer for D is R. So I think B is the correct option, that we can write the reduction of reduction of the compounds in the form of forming of acid in any solution. So I hope this question is clear. Let's move to the fourth question. So I think so this reaction is like this: half M2, it is in front of this only. These are the products MnO2 solid plus 2H plus. So this is the overall reaction given, and we have to identify the electron donor and electron acceptor. So electron donor will be something which is getting oxidized, and electron acceptor will be those which is getting reduced. So again, I'll give you 3 minutes. We can also find out the electron donor and acceptor on the basis of the charge on the compound. So I'll give you 3 minutes. Just take your time and write the correct answer in the chat box.
Madam, answer D.
So D is the correct option. So let's see what are the charges of the compounds involved here. So we have Mn2 plus H2O plus half O2. The products are MnO2 solid and 2H plus. So here we can see the charge of Mn is here 2 plus. Let's see what is the charge of MnO2 in Mn manganese in MnO2 solid. So let's assume it as X plus 2 into, we know for oxygen it is minus 2. It is 0 because there is no charge on the compound. So X is plus 4. So here the manganese is plus 4. And from hydrogen it is plus 1 and here on plus 1. So let's see for what is the oxygen. So here we can see oxygen has minus 2 charge, but we know that compounds having same atoms have 0 charge, so it is here 0. So from 0 it is going to minus 2, and for Mn it is going from 2 plus to plus 4. So here it has donated its electron, so it is the electron donor, and oxygen has accepted the electron, so it is the electron acceptor. So we have to find out first the electron donor, that is Mn2 plus, and electron acceptor is oxygen, that is O2. So let's move to the fifth question. So the question is, using half reaction in standard books, determine the PE for the following oxidation of ammonia aqueous to nitrate by reduction of oxygen to H2O. So first I'll request to oxidize these half cell reaction, that is oxidation of ammonia to nitrate, and the second half cell reaction, that is reduction of oxygen to H2O, and then we will proceed further in the question. So I'll give you 5 minutes to balance this reaction, and then we will see how to solve this question. Okay, after balancing, I will give you the values of standard value of PE naught for these two reactions so that we can solve the question further. Okay, let's first balance the reactions. So first is oxidation of ammonia aqueous to nitrate. So let's write the oxidation half cell reaction. It is ammonia aqueous is forming nitrate ion. So we have balanced similar reaction in question number 1. First we'll balance everything except hydrogen and oxygen. So nitrogen is balanced here. Next we balance oxygen by adding H2O. So 3H2O. And finally we balance the hydrogen atoms. So it is 9. So 9H plus. And finally at last step is to balance the charge on both the sides. So on the reactant side the charge is 0. So the charge should be 0 on the product side also. So it is, we will add 8 electrons. So the overall charge on both the sides is 8. Sorry, it is 0. So now let's write the reduction half cell. Oxygen is getting reduced to form H2O. So first we'll balance oxygen, so 2H2O. Next we are going to balance H hydrogen, so 4H plus. And finally the charge on both sides, for this we will add 4 electron on the reactant side. So now next what we are going to do, we will refer the table which I have showed you in question number 1, and we will find out what is the value of PE naught for this reaction and what is the value of PE naught for this reaction, and finally we will find out what is the overall PE naught for this oxidation reduction couple. So if we write the overall reaction, so what we will do is, okay, for oxidation of O2 gas to H plus, the value of PE naught is 20.78, and for NH3 aqueous to nitrate, the value of PE naught is minus 13.78. Sorry, 73, it is directly given. We have to find out the overall reaction and the overall PE naught for this reaction. We have just added these two reactions, so the P naught values will also be added, that is 20.78 plus minus 13.73, so it will be 7.05. So directly we can take the values of P naught from the table. So let's move to the next question. So the question is, water at pH of 7 exists in equilibrium with a gas containing 21% oxygen and 0.05% ozone by molar basis. The following equilibrium exists and the corresponding P naught value is given. We have to determine the P for the above reaction. Assume atmospheric pressure is 1 atm. So we have to solve this question to find out the value of P for the given reaction. So I'll give you 5 minutes. Just take your time and try to solve this question.
Madam, tell the answer. Hello.
Yeah, I'm here only.
Yes, madam. Tell me the answer. Tell me. Tell me the answer.
Okay, just give me a minute. I got disconnected from that device. So we have been given pH is 7. So let's write on everything. We have been given the P naught value. So, and also the percentage of oxygen and ozone are given in the basis of moles. That is, if 21% of oxygen and this much percent of ozone in the molar basis. So let's see. We know we have to find out the PE. So we know that P is equals to PE naught minus NH by NPH plus 1 by N log oxidant by reductant. So here we have PE naught is, okay, we have P naught is 35.06, number of H plus is 2, and number of electrons is also 2, and pH is already given in the question, it is 7. And since I have written in the form of uh, plus 1 by N oxidant to reductant, or we can write 1 by N, that is number of electrons is 2 log the reduced form, that will be O2. So we have around 21% of O2, so 0.21 upon the oxidized form. Either we can reverse these or and take a minus sign at the front. So I have done that. So I will write the reduced form first and the oxidized form at the denominator. So it is around 0.05, and this is given in the basis of molar basis. So we can directly take the percentages as molar concentration, and this is the final equation. We just have to solve this and find the final value. So after solving it, we are getting around 26.75 as the value of P at given conditions. So let's move to the next question. So the question is, determine the ratio of total dissolved arsenite, that is a arsenic 3 form, to total dissolved arsenate at a pH of 6 and a PE of 5. So we have been given pH, we have been given the value of PE, and we have been given that we have to find out the total dissolved concentration of arsenite to arsenate. So we will use the reduction half cell for arsenate getting reduced to arsenite. We will also use the standard we will also use the table to find out the PE naught value at the standard conditions, and finally we will use the previous equation, that is P equals to PE naught minus NH by N pH and all. We will use that. to find out the concentration of arsenide to arsenate. So let's first go to the table. So okay, just take 2 to 3 minutes. Try to write the balanced equation for conversion of arsenide to arsenate, and we will then proceed further. Okay, let's see. So the arsenate form is exists as AsO4 3-. Here the oxidation state of arsenic is +5. So it will accept electrons and it will get reduced and it will form arsenide, that is AsO3 3-. So let's first balance this reaction. So arsenic is already balanced. We will next balance oxygen. So there is one oxygen less in the product side. So we will add one H2O. Next we will balance the hydrogen atoms. So there is, after adding 2H plus, hydrogen is balanced. Next we will balance the charge. So by adding 2 electrons on both the sides, the charge is -3. And for this reaction, the PE naught value from the table is 2.64. And as we know, P equals to PE naught minus NH, that is number of hydrogen atoms, ions, divided by number of electrons into pH, plus 1 by N log oxidant form to the reduced form. So we have been given the P is 5, PE naught is 2.64, number of hydrogen H plus ions is 2, it has accepted 2 electrons, pH is 6, plus number of again electrons, it is 2 into. So we have to write the oxidized form, it is AsO3 upon As O4 3 minus. So we will solve this equation and we can get the ratio of what will the concentration of arsenite we have to find for arsenite to arsenate. Solving this, we will get the final value of arsenic 3, that is ASO3 3 minus. I will request to check these values to recalculate on your side and confirm whether so question is, what is the theoretical oxygen demand of cresol? The formula for cresol is given and it is getting oxidized to CO2 and H2O, and we have to find out the theoretical oxygen demand in milligrams of oxygen per gram per milligram of carbon. So after oxidation, generally CO2 and H2O are the products which are formed. So you have to first write the oxidation half cell reaction in which cresol is getting oxidized to CO2 and H2O. You have to balance that reaction, and by using the stoichiometric coefficient of all the compounds on the reactant and product side, you can find out how many moles of oxygen is required per mole of the compound, and we can finally find out the value. So I'll give you 5 minutes to solve this question and write whatever value you are getting in the chat box. So I will also request you to please try to solve these questions. Okay, let's start solving this question. First, we will balance the oxidation of cresol to CO2. So what we'll have to do is, so this is the reaction. So first we'll balance the oxidation half reaction in which cresol is getting oxidized to CO2. So first we'll balance this reaction. Let me rub everything. So let's so it's getting oxidized to CO2. Let's balance this. 7 carbon, so 7 CO2. Next we'll balance oxygen. This is 7 to the 14, but here it is only one oxygen. So we will add 13 H2O. Next we'll balance the number of hydrogen atoms. So it is 13 to the 26 plus 8. And finally we will balance the number of electrons. So charge is 0, so it will be 34 electrons. So it's carbon 7, 7. So everything is balanced. Next we will balance the reduction half reaction. So oxygen is the oxidizing agent, so itself it will get reduced. So oxygen will get reduced to form H2O. So we will balance oxygen, 2 oxygen, so 2 H2O. Next balance hydrogen atom and finally balance the charge. So this is the reaction number 1 and this is reaction number 2. So finally we will add these reactions to get the overall oxidation reduction reaction. So we will multiply, we will add equation 1 plus 17 times of equation 2. So let's add these. So we will have C7H8O plus 17O2 and we will have 7CO2 plus 17 to the. So after multiplying it by 17, okay, we will also have to multiply the equation 1 by 2, then only it will get balanced. Yes. So 2. So this is the overall balanced reaction. We are multiplying equation 1 by 2 and equation 2 by 17 to balance the charge on these two reactions and cancel the number of electrons. So after multiplying equation 1 by 2 and 2 by 17 and adding these two, we are getting, this is the final step. We are also H plus ions is getting cancel out and we have balanced the finally H2O. So from this reaction we can see that 2 moles of cresol requires 17 mole of oxygen to get oxidized to CO2 and H2O. So let's 2 moles require 17 moles of O2. And also we can see that for in each, so let's first write for 1 mole of cresol will required by 17 by 2 moles of oxygen. And also in 1 mole of cresol there are 7 moles of carbon. Okay, there's no slides. So let me first add H8O. So 1 mole of cresol has 7 moles of carbon, and just now we have seen that 1 mole of cresol requires 17 by 2 moles of oxygen. And we have to find out in the terms of milligrams of oxygen per milligram of carbon. So oxygen demand will be 17 by 2 into 2 into 16. This much gram of oxygen per mole of cresol. And to find out the oxygen demand in per gram of carbon, so it will be 17.2 into 2 into 16. Dividing these, we will get the final value, which is around 2.5 milligrams oxygen per milligram of carbon. So let's move to the next question. So question number 9 and 10 are connected. So I think this question we will solve by Mintek. So question is, a soil sample was analyzed for manganese traces due to recent contamination for nearby factories. The soil solution containing this much of manganese and this much of carbonate with 4 milligrams per liter of dissolved oxygen. The pH of the soil is given and we have to find whether the solid rhodochrosite will form or not. So we will feed everything in Mintek and we will see if rhodochrosite is supersaturated or not. So this is the mental interface. We have been given pH as pH is given as 7.5. So we will fix the pH at 7.5. We have been given manganese at 10 raised to minus 5. We will add it. We are given total carbonate. It is 10 raised to minus 2. And we are given oxygen in milligrams per liter, that is 4 milligrams per liter. So let's see whether we have added everything. So we have added everything, manganese, carbonate and oxygen. Also we have to find out whether rhodochrosite will precipitate or not. So let's run the Mintek. So this is the overall result which we got. So we will go to display saturation indices. And we can see here that rhodochrosite supersaturation index is 0.772. Since it is greater than 0, it means the solution is supersaturated with all these solids which are shown here in red color. So rhodochrosite is also supersaturated. So the answer for this question will be Okay, the correct answer is B. That is, the solution is supersaturated with rhodochrosite. So next question is, the VE Mintech database includes the reactions shown below for the formation of mineral magnetite. What is the chemical formula for magnetite and the oxidation state of manganese in that solid? So let's go to V Mintech. We'll go back to the input menu and we will add the magnetite. So let's limit our list to the components which we have added. Okay, we have magnetite. So we can see that, let's add it. So magnetite is MnOH. Let's, so we can see that manganese, Mn, this is +2. It is forming magnetite, that will be MnOH. So this is the compound manganetite. So Mn2 plus is forming magnetite. So this is the formula for magnetite. It is, okay, we have to find out the oxidation state of manganese in that solid. So let's assume it is X plus -2 for oxygen and for hydroxide we know it is -1 and overall charge is 0. So the oxidation state of manganese in magnetite is +3. So okay. So option C is the correct answer. So these were the previous year questions. So this was the material for week
Madam,
11.
please, madam, please, question number 9. Again, the question number 9, please answer.
Okay, okay. So what you are asking?
So what is the answer of these questions of 9?
Okay, okay. We have seen that the supersaturation index was greater than 0 in the V Mintech. Okay, let me show you in the V Mintech.
The answer is how much, sir? What is the answer? Already I know this thing, but what is the answer?
Just wait a minute. So after going to saturation indices, we can see that the compounds which are shown here in red. So is my screen visible? So all these compounds which are in red are having supersaturation index of greater than 0, and we know that if sub compound has supersaturation index greater than 0, then solution is supersaturated with respect to that compound. So it was asked, the question was for rhodochrosite, and we can see that the saturation index is 0.772, which is greater than 0. So the solution is supersaturated with respect to rhodochrosite. So the correct
Okay.
answer here is oversaturated.
ठीक है.
Supersaturated and oversaturated are
Thank you.
same.
Okay, okay, madam.
Okay, do you have any other doubt?
No, any other no doubts, sir, madam.
Okay. Okay, these were the question for week 11. There is only 1 week left. That is week 12 material. We will discuss on next Sunday from 3 to 5 p.m. And I think there will be one more session of 1 hour in which I'll be discussing about overall syllabus of this course, followed by 1 or 2 questions based on some topics like pH and redox. And that will be all for this course. And then I think we have exam on, I don't remember the date for the exam. We have exam on October only. And
29th of October. 29th of October
okay,
for
for
exam.
this subject, it is 29th of October. Okay, okay. Okay, so thank you so much for joining. Have a nice day. We will meet on next Sunday. Thank you.
Thank you very much. Thank you.